Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Kenneth Haskin. As usual, we first complete statement. Gallium phosphide energy gap equal to 2.26 electron volt and zinc selenide energy gap equal to 2.87 electron volt are commonly used to make LEDs, that is light emitting diodes. Okay. What is the most prominent emission wavelength of these devices and what color is the corresponding light? First helping tool, momentum of a photon P is equal to photon energy capital E divided by speed of light in vacuum C. This alternatively becomes equal to hf, where h is Planck's constant and f is the frequency, divided by c, speed of light in vacuum, as in previous step. This alternatively becomes equal to h, Planck's constant, divided by lambda, where lambda is the wavelength. Okay. Tool number 2 has been discussed so many times, so it is omitted or ignored from further explanation. Okay. Tool number 3, approximate correspondence between wavelengths of visible light and color. Okay. Wavelength range in nanometer, color description. Okay. Wavelength range from 400 to 430 nanometer is violet. From 430 to 485 nanometer is blue. From 85 to 560 is green. From 560 to 590 is yellow. From 590 to 625 is orange. From 625 to 700 is R. Dear students, I very clearly remember that in our school life, in my school life physics, we were well familiar with this spectrum, but 1, 2, 3, 4, 5, 6, at that time 7 colors, Wib Joyer was the word which I had remembered to recollect these colors in mind. And after violet, indigo, Wib Joyer, after violet, indigo color was present, but now I do not know what has happened to indigo. In my subsequent videos, I shall emphasize or try to find out that why it has happened that in about 83, 84, 85, 86, 7 colors had to be shown as a spectrum, and 7th color was indigo, but now indigo is not present here. Okay. Anyhow, now we come to its solution. We know that momentum P is equal to E over C is equal to F over C is equal to H over lambda. This implies that lambda is equal to HC over E. Okay. This is the same as we have described in tool. Okay. That is momentum equal to E over C, energy of photon divided by speed of light is equal to hf over c, where f is the frequency, h is the Planck's constant, is equal to Planck's constant, h over lambda, that is wavelength, and this alternative becomes equal to lambda equal to hc over capital E. As per existing situation here, this E is equal to Eg, equal to energy gap. Okay. So this E and Eg, where G is written as a subscript of E, that is energy gap, are both one and the same thing. Okay. Now we come to case 1, which is gallium phosphide. Lambda equal to hc over eg, energy gap. Dear students, in helping tool in which a very comprehensive table is shown in which various physical constants have been given their exact value. We know that combined value of Planck's constant h and speed of light c is given as 1240 electron volt nanometer divided by Eg is equal to 2.26 electron volt, which we have calculated in the previous step. Okay. Yes, this is given in the statement. Eg for both cases is given in the statement. Eg for gallium phosphide and Eg for zinc selenoid, both are given, and hence just simplifying, here electron volt will be cancelled with electron volt, and our answer will be lambda wavelength equal to 548.67 nanometer. From the table which we have shown this, according to this table, if we compare that value in accordance with this table, then we come to conclude that this color is green. Similarly, now we come towards case 2, zinc selenoid. Here lambda becomes equal to this 432.05 nanometer, and if we compare this value with this table, then we conclude that its color is blue. Okay, so this is the end of our problem. Till next video, Allah Hafiz.